Okay guys, in this video we are going to look at something known as geometric transformations, or just in fact like shape shifters. Okay, so let's meet these transformations. So first of all, transformations, what they are is they are ways to change a shape's position, orientation, or size. Okay, it's like math is like playing with like action figures, and in this case the shape is the action figure. Alright, so leave the pre-image. The original shape, you call that your pre-image. Okay, it's like your before photo. So before the whole transformation happens, you have your pre-image. Then you have your image, and that's the new shape. Okay, so after you move it, you have this image. It's the after photo. Okay, so that's just a basic vocabulary. But now we're gonna meet and see what these transformations actually are and the different types. So first we have translation. Okay, this is the slide. The shape just slides to a new spot, and we'll look at all of these more in depth. Then we have your reflection. Okay, everyone should know this. This is just a flip. The shape flips over a line like looking in a mirror. Then we have your rotation. This is probably like one of the basic ones. This is just a turn. Okay, the shape spins around a central point. Then we have a dilation. This is your shrink slash grow. So the shape, it changes size, but it keeps the same shape. Okay, so let's first talk about the translation. Now, in translation, that's their simplest move. You just slide the shape from one spot to another. There's no turning, no flipping, and no resizing. Okay? All you do is just slide the shape. Okay? Now, translation, and this is a key property that the first, your pre-image and the image, they are 100% congruent. Okay? They are identical. Okay, and this congruent word, that's just a fancy way of saying identical. Okay, so all side lines are the same, all angles are the same. It is exactly the same. It's just a new location. Okay, so now let's move on to the reflection. Okay, so what is a reflection? A reflection flips a shape over a line, and that line, that is a special line, and it's called the line of reflection, and it's also known as the mirror line. So every point on that new shape in the image is the exact same distance from the mirror line as is the original shape. Okay, it's just on the opposite side. Okay, and here's a lame math joke if you feel like pausing the video and checking it out. Okay, now let's go to the rotation. Once again, super easy, all you do is turn. A rotation turns a shape around a fixed point called the center of the rotation. To do it, you need three things. A center to turn around, like the origin, an angle to turn it, so like 90 degrees or 180 degrees, and a direction. You have clockwise or counterclockwise. Okay? Okay, so now let's talk about dilations. What is a dilation? So it is a change in scenery and size. This is the one transformation that changes the size of the shape, and it's not congruent anymore. It gets bigger or smaller, okay? And it's controlled by a scale factor. And we talked a lot about this in a previous video that we made on dilations. All you do is just multiply the coordinates by this remember, this is the key property again, that the image and the pre-image for dilations is that they are similar. They are not congruent. The new shape is similar to the original. It is still the same shape, okay, so all the angles are the same, but it is a different size, okay? It's like a big photo and a wallet size photo of the same person. The shape is the same, but the size is not, okay? So here's the big summary. All a translation does is it slides, a reflection flips, a rotation turns, and a dilation resizes. Okay, so for a translation, reflection, and rotation, the shapes are like the pre-image and image, they're congruent. But for dilation, they are similar. Okay, they are not congruent. Okay, and see for all these transformations, they're always similar. Okay, that's why you call them similarity transformations. Okay, so if you have any questions, go ahead and put in the comments below. And thank you for watching.